All right, here we are back again in our first chapter in our study of Python. What I'd like to talk to you today is the topic will be mistakes in code. Now, let me go ahead and introduce the usual name for this. The usual name for a mistake in code is a bug. The story that I've heard about why it is that they're called bugs is that if you go back in time to the early days of computation using computers, actually, programs were stored not, like on submagnetic media or in the cloud like they are today, but rather they were stored on punch cards. You can look that up. There were cards, rectangular cards that actually had holes punched in them that could be read by a machine. So that's how the data would get in to the computer, the actual program. And you would actually have multiple stack. You would have multiple cards in a stack, and then you would, have a machine that would actually punch the holes in the cards, and then you would take the cards in, and they would be, flipped through and read, and the program then would be input into the computer. And the story is that there was actually a moth stuck in between two cards. I don't know if this story is just apocryphal or if it's really true, but there was a moth stuck in between two cards, and of course this caused a misread. So the mistake was due to literally a bug, and then the word bug came to be used universally for a mistake in code. Now, I'd like to talk about two kinds of bugs today. This is a topic to which we will have to return many, many times because you will find that mostly what you do when you write code is you actually debug. That is, you remove the mistakes from your code. Now, early on here, when we write very simple programs, it will be a relatively simple matter to debug, but as the programs we write grow in complexity, well, so too will the bugs grow in complexity and subtlety, and sometimes they will be very difficult to find out. And very often what you will do is you will simply debug your code until it is correct, or you believe that it is correct anyway. So, I mean, this is something that we will spend a very long time on, correction of mistakes. That is, we will debug our programs. Now, what I wanted to do is to talk about bugs of two types. Now, the distinction that I am about to make is not so incredibly common, at least the language that I will use, though the idea is surely straightforward and everybody who codes knows. So the two kinds of bugs that I would like to discuss are so-called stop and go bugs. Stop and go bugs. Now, what I mean by a stop bug is this. Uh, a stop bug is one that actually stops the execution of the program. Okay, I mean, you know what it's like to write a program, right? We've written some simple programs. I'll tell you what, we'll write a simple program. So let's say the radius of a circle is 5, and then the area is 3.14 times, what's area of circle again? Pi r squared, right? So pi times r squared. And then we could print something like the area of a circle, circle of radius. Okay, so we'll print that string and then a comma, and then we'll print the value of r. A circle, the area of a circle of radius r is, and we've written a program on almost identical to this before, is a. Okay, so look, and I run this, and hey, no bugs apparently. But the first kind of bug that I wanted to discuss, the one that I mentioned previously, a stop bug, that's what you get when, in the execution of the program, Python doesn't know how to interpret the symbols that are present. It doesn't know what it is that it is supposed to do. Or perhaps it's been asked to do something that is impossible for it to do, in which case it stops execution of the program and it prints out an error message in the console. You've seen these before, those bright red error messages. So notice what I did. I went back to line number 2 and I actually deliberately introduced a bug. And this is a bug that I see with fair regularity because students forget the distinction between Python and mathematics. In mathematics, you can type something, you can write something like 3.14r, and then what's understood there is that we mean the operation of multiplication. But in Python, that won't be understood. You have to actually use the multiplication symbol, the star, if you wish to multiply. So if we make this mistake, if we think that we can do what we do in mathematics, then look. Okay, so let's read through the entire error message. Before I said, not so important yet to read through them, but let me begin to emphasize to you that you should read through the error messages. So let's see. File main.py. Okay, so it tells us that the program is contained in a file called main.py. So I just opened files again on the left-hand side, and sure enough, that's our only file, main.py, and that's where the code resides. Line 2, oh, that's helpful. So it tells us where to look, and you I'm sure will understand that if you've written a program that contains hundreds or thousands of lines, the identification of the line on which the mistake occurs is enormously helpful, of course. Oh, and that it actually reproduces the line, and that it points at the first character that it didn't know what to do with. Okay, so imagine that you're Python. So there you are on line number 2. You see the A, and then you see the assignment token, which I have told you not to call the equal sign. It's not mathematical equality. It's the assignment token from Python. So Python sees A and then the assignment token, and then it sees 3.14, and that's cool so far, right? That could be the start of a perfectly syntactically correct line of Python, and then immediately after that 4, it sees the R, and then at that point it doesn't know what it is that it's supposed to do. Okay, because that R is a variable, but it doesn't know how that R is supposed to be related to the 3.14 that precedes it. So Python just doesn't know what to do. So it points the arrow at that R and then says that this is a syntax error, that is invalid syntax. And syntax is just, I expect you have a sense of what that is. Syntax is just like the rules of how you put symbols together so that Python knows what they mean. So Python has told you, basically, I don't know what that means. Okay, so there's a syntax error for you right there. So pi r squared is now indicated with multiplication, so I can run it and we don't get the syntax error. Okay, or we can introduce another syntax error if we want. I've told you that the syntax of the print command is this: if we wish to print multiple objects on a single line, we must separate them by commas. So I left the comma out on line number 3, and oops, yep, invalid syntax. It doesn't know what to do with that, and it says line number 3, so that is correct. And of course, your syntax errors, your stop errors, and syntax errors are one very common variety of stop error because the program stops with them. You won't do yours deliberately, but they absolutely will happen. You will make, I would guess, hundreds of syntax errors throughout the year, and then you will have to correct them. There are other kinds of stop bugs as well that are not syntax errors. So here's another program that we might write. Let's do a little bit of division. Okay, so let's have a couple of variables. I don't know, an x, a 3, and a y, a 0, and perhaps you have a sense of what the error will be. The quotient of x and y is, oops, double, is, and then I think we've seen an example of this before. We can absolutely do computations inside of a print command because, well, what does Python do? Python looks at that and goes, oh, I have to do the computation. Then it does the computation, and then whatever results gets printed to the screen. Okay, so let's make sure that my code is what I intend. So x is assigned the value 3, y is assigned the value 0. And then we print the string, the quotient of, and then the value of x, and then the string and then the value of y, and then the string is, and then we do the computation x divided by y. Okay, so let's actually run this and see what we get. Ooh, nice. Okay, I wanted to show you another kind of stop bug. So what happened is this, is at the very end of our program on line number 7, we attempted to do division by 0. And just like in mathematics, that is not defined. That cannot be done. So Python actually stops the execution of the program and tells us that we have 0 division error. Now, there are many kinds of errors that you will encounter in Python, and we won't take the time to catalog them, though we will talk about many of them. Just do know that this is a kind of bug that a program can contain. That is a stop bug. Now, let's talk about a go bug. What's a go bug? Well, a go bug is one in which your program actually executes from start to finish and you don't get any error messages, but the program doesn't do what you want it to do. Instead, and this is a little joke, I always thought it was funny. Instead, it does precisely what you told it to do. And of course, the problem is that what you told it to do is not what you wanted it to do. Okay, so let me show you a simple example of this. Now, I don't know if this is something that you would actually do or not, but you might. You might, I suppose. So let's say that we wish to compute the area of a circle. And then notice that I've inserted parentheses on line number 2. So what I have to do then is this, is I have to what I have told Python to do on line number 2 is to first multiply the r by 3.14 and then to square the result of that. And that's not what is supposed to happen. Instead, what is supposed to happen is that we're supposed to square r and then multiply that by 3.14. And the result will be different, okay? If you look back over in the console, you see that the result of the correct computation is that the area of a circle of radius 5 is 78.5. But notice now that we get something quite a bit larger. Okay, now I don't know that you would make this mistake, but it is a mistake nonetheless. Okay, there's another name for a mistake like this. It's sometimes called a semantic mistake, to distinguish it from a syntactic mistake. Again, a syntactic mistake, a syntactic bug is one that has to do with just, the arrangement of the symbols. Python doesn't know what these symbols mean, okay? It doesn't know what to do with them, so it stops and tells you that. A semantic bug, on the other hand, is one where the syntax is correct, okay? So Python knows precisely what it is that it's supposed to do, and it does precisely what it's been told to do. However, what it was told to do is not what the programmer really wanted it to do. So the programmer made the mistake, okay? What the program means is not correct, okay? Like in this case, what the program means is multiply r by 3.14 and then square the result instead of square r and then multiply the result by 3.14. Okay, so what it means is wrong if it's supposed to compute the area of a circle. Okay, now you will encounter bugs of both types in your bugs of both types in your programs. You will encounter stop bugs. And in a way, those are easier, right? Because Python has told you that there is a problem so severe that it cannot actually execute your code. Now, sometimes it is difficult to debug those, but you've got a leg up to begin with because you know you've got a mistake, and Python at least has an idea of where the mistake actually occurs. With a semantic bug, that is with a Go bug, on the other hand, those can be really hard, right? And sometimes you don't even know that it's there because you hit the run button, the code executes, you get some kind of output in the console, and perhaps it looks right, and you go on about your business, right? You think your code is correct, but actually your code is not correct. Now, this can happen in multiple ways. Perhaps the output is never correct. Perhaps it's correct sometimes, but not other times. That second kind of case where the output is not correct in some instances, those can be the really bad ones. And that's why it is that we will work in this class systematically to test our code with many possible inputs to verify that it is correct. But yeah, those kinds of bugs can be bad, because you've written this code and you get some output that is the program never crashes. A crash bug is a stop bug. And it looks like in some cases, at least, it gets the right input, it gets the right output, but it's not always right. Perhaps you didn't know that, and then problems crop up later on, and then you have to go back and rethink your code. And yeah, Go bugs can be bad. Okay, so if you're a programmer, you're a debugger, and actually, mostly what you will find is a debugger.